Alright, so we're going to have a look through the physical world section of the 2014 Year 9 Science exam. Okay, here it is, question 1. So from this list of words, you had to choose the best word or words to answer these questions. Note that it said more than one of these can be used in each answer, and you may not need to use all of them. So the first one, 3 examples of forces. There are several options that you could have chosen. I've written some of them here. You could have used unbalanced force, static electricity, push or pull, magnetic repulsion. You could also have used gravity, force, weight, or friction. Those are all forces. Some people didn't read the question very well and didn't do 3 examples. Also, some people just did push or pull and one other thing, like one other example. So I accepted push or pull as 2 in those cases. Non-contact forces are forces where the objects are not touching. So examples of that are static electricity, magnetic repulsion, and gravity or weight. What causes acceleration? The best option here was force, unbalanced force. That's where you've got forces on an object that are not balanced. We also accepted force or any other force that would cause acceleration, such as magnetic repulsion, gravity, etc. Okay, which instrument measures force is a spring balance, and what the unit is Newton. And the term describing the quantity of matter is mass. So if you got, let's take a look at the marking schedule so you can see the way that we marked the exam. Here it is here. So here we have the question number, so question 1, and here are the answers. And this is the criteria for achieved. So if you got at least 6 marks, 6 ticks, then you got achieved for that question. And if you got at least 9 out of, I think there were a total of 10 available, then you got merit for that question. I didn't accept friction for what causes acceleration, because that actually causes a deceleration or slowing down. Okay, question 2. A mountain bike rider rides her bike over a number of different surfaces. During this time, friction and other forces act on her and her bike. During her journey, she rode across the following surfaces, and then you're required to match the surface number with the force required to keep her and her bike moving. So here's the correct answers. Well, actually, let's talk through it. So the lowest force was, let's start with the lowest force, was 50 newtons. And that's going to be this one here, surface 4, level smooth road with the wind behind her. The next lowest was 100 newtons, and that's going to be surface 1, which was a level smooth road, so similar, but didn't have the wind pushing her along. The next lowest was, the next 2 were 1,000 and 1,500, and that's going to be surfaces 2 and 3, so both are on a slight incline. One's over grass, one's over gravel, depending on the length of the grass, but in this instance I've said that grass is going to be slightly harder to ride over than gravel. And the largest force, 4,000 newtons, that's going to be when you have a very steep incline, because you've got gravity working against you. So we accepted these the other way around, 2 and 3. You could have had 2 here and 3 here, and we accepted that, that's fine. Marking schedule for this one, so there's the correct answers. If you got 2 of those correct, so if you got any 2 correct, you got achieved. Any 3 correct was merit, and 4 or all of them correct was excellence. Okay, question 3. Sorry, not question 3, question 2b. Question 2b asks you to draw a diagram showing the forces acting on the woman and her bike as she rides. So we're told that she's going from surface 4 to surface 5, and if we look back here, we see that she's going from a level smooth road with the wind behind her onto a very steep incline on a rough road. So she's just come off the road and onto the incline on a rough road going uphill. So that's where she is now. And these are the forces acting on her. We have thrust, because she's pedaling her bike, so she's providing a thrust force forwards. we have friction, so that's just due to the surface she's riding over. So there's friction between the tires of the bike and the surface she's riding on, and there's also air resistance. So the air, she's riding through the air, and the air is resisting her motion. Now you'll note here it said that the size of the arrows is important. So you should have drawn the friction arrow and friction or drag or air resistance, we accepted any of those words, larger than the thrust arrow, and that would indicate that she's slowing down. Key bit of information there, she finds herself slowing down. So we know that because she's slowing down, the force in this direction must be larger than the force in this direction. She's going to have a weight force acting directly down towards the earth, so her weight force or gravity, and the support force, you don't need to know this at this level, but support forces always act perpendicular to the surface. It didn't matter if you drew support vertically upwards, or in fact if you drew weight going down this way, that's fine, we accepted that. You don't need to know that at this level. But those are the four forces: thrust, support, weight, and friction or drag or air resistance. If you, let's have a look at the marking schedule. There's our diagram there again. If you got arrows and labels for at least two of the forces, then that was enough to achieve. And if you got arrows and labels for all four forces, that was enough for merit, regardless of the size of the arrows. So even if you had the size of the arrows the same for thrust and friction, if you got all four, then that was enough for merit. Or if you just got two, let's say you just did the thrust arrow and the friction arrow, but you drew the friction arrow larger, then that was also enough for merit. And for excellence, you just had to have a complete answer. Like I said, it didn't have to have, even for excellence, you didn't have to have the arrows as I've drawn them here. As long as you had four arrows in approximately the right direction, with the friction arrow larger than the thrust arrow, then that was enough for excellence. Right, on to the next question, which was complete the table below by listing ways that friction hinders us and ways that friction can be reduced. Now some people, I think, misunderstood the question. They wrote down ways that friction helps us. Hinders us means like ways that it's an obstacle or that it causes problems. So an example was given that it slows things down. Other examples included friction wears things out and also causes unnecessary heat. Other people suggested different things which also were accepted, like losing energy. In other examples, I accepted any reasonable way in which friction hinders us for that one. Ways that friction can be reduced included lubrication. Now some people, for their other example, gave things like oiling or water. I didn't accept those because those are actually examples of lubrication. So you had to give different examples, different ways that friction can be reduced. And other ways were including rolling, so making objects round, which includes things like using things like ball bearings, and streamlining, so making an object more streamlined so that its shape has less air resistance. You could have also said pushing air in between objects, and polishing surfaces. Those also reduce friction. And the marking schedule was that if you got at least one of each, so if you got at least one tick in each of these columns, then you achieved that question. Okay, question 4 tells us mass and weight are different quantities. Let's scroll down a bit. Explain the difference between mass and weight. Include units in your answer. Okay, so here is the correct explanation. Mass is just the amount of matter in an object. It's how much stuff an object has, how much matter is in an object. Now, quite a few people said that matter is the amount of space an object takes up, but this isn't true. If you think about it, you can have a light object which takes up a lot of space, like a balloon. It's an object, it takes up space, but it's not heavy. So, but you can also have a small object that is very dense, which has more mass. So it's not the space it takes up; it's just the amount of matter in an object, and the units are either grams or kilograms. And then weight is the downwards force on the object due to gravity. So it's the force that gravity exerts on the object's mass. So mass is how much matter is in the object, and weight is the force that gravity has. So it's the downwards force on the object due to gravity. And the units for weight are newtons. The way the marking worked for this one is that if you got one correct, so if you got one correct definition with units, or if you had both without units, then that was enough to achieve. If you had both definitions correct with units, then that was enough for merit for that question. So quite a few people didn't read the question carefully enough, and they didn't include units in their answer. You must read the question carefully. Okay, next question. Said, a man's mass is 80 kilograms and his weight on Earth is 800 newtons. One of these two quantities would change if we went to the moon, where the gravitational attraction is 1.6. Name the quantity that would change, calculate the new value, and include units. Okay, the quantity that would change is his weight. As we said previously, mass is the amount of matter in an object. So the amount of matter in an object doesn't change regardless of where the object goes. It's the same, the amount of matter in the object is the same on Earth as it is in the moon. The quantity that changes is his weight, because weight is the force on an object due to gravity. Now on Earth, the gravitational attraction is 10, and we can see that because his mass of 80 kilograms ends up being a weight of 800 newtons. But on the moon, the gravitational attraction is 1.6. So the gravitational attraction is less on the moon than it is on Earth, which means that the downwards force on the object is going to be less on the moon than it is on the Earth. So weight is the downwards force due to gravity, and because the gravity is less on the moon, the downwards force, which is the weight, is also going to be less on the moon. And this is how we calculate it. His new weight would be, and weight is equal to mass, which stays the same no matter where you go, times gravity, which is our gravitational attraction. So if we were on Earth, this would be mass of 80 kilograms times by 10, gravitational attraction of 10, and that's why we get 800 newtons for his weight on Earth. But on the moon, the gravity is no longer 10, it's now 1.6. So we go weight is equal to mass of 80, still the same, times 1.6, that's our new gravity on the moon. And the answer to that is 128 newtons. You must have the units. Some people forgot the units. And the way this one was marked was, if you said that his weight would change, which is correct, then that was enough to achieve. If you tried to calculate his new weight by doing something with the existing quantities of 800 or 80 and using 1.6, so a lot of people did things like dividing 800 by 1.6 to get 500. So if you used either of these two numbers and multiplied or divided by 1.6, then that showed evidence that you're using the new gravitational attraction on the moon and the existing quantities to calculate a new weight. Even though it wasn't quite right, we still decided that was sufficient for merit. And if you correctly said that his weight would change and worked out that it was going to be 128 newtons, then that was enough for excellence, but you must have had the units there also. Alright, next page. This one said, question 5, start off by saying include units in your answers to the questions below. Key sentence, a lot of people didn't manage to do this. So the first one was, what is 2 hours 15 minutes expressed as a decimal number? Now this was a tricky one, and a lot of people didn't manage to get it right. So you've got 2 hours, and you want to express 2 hours 15 minutes as a decimal number. The way you have to do it is think about the 15 minutes, you have to think about that as a fraction of an hour. So 15 minutes is quarter of an hour. So we've got 2 hours plus a quarter of an hour, or 2 1/4. So that's the same as 2.25, because 0.25 is the same as 1/4.